Hi, this is the continuation of the last session regarding the firewalls. We are back to this proxy firewalls now, which is the last type. Can also be called as application level gateways or cloud firewalls. Proxy firewalls operates at the application layer to filter incoming traffic between your network and the traffic source. The same function this also is going to have. But what is the extra specialization or extra function of this proxy firewall is, see, proxy. What is proxy? It is like a duplicate servers. So instead of sending all the traffic to the servers, the main servers, what it is going to do, it will be acting as a proxy firewall, like proxy server, so that the firewall will also act as a proxy server. So if at all any traffic is required by the incoming, like inside the network, the users in the inside network or the outside network, if the same data has been already sent or received by the proxy file, same request or data is already has been sent between the outside and the inside network, then it can be cached by this proxy firewall, so that in the future if the same data is requested by the people in the inside network or the outside network, it will give the data, it will serve the data to the people of like outside and the inside network. So this is how the proxy firewall works. So it is not going to disturb the server for each and every request and the response. Instead, it will also act as a server. The firewall is going to act as a server by providing the data which has been already sent or received by it. Next, the firewalls are delivered via cloud-based solution or another proxy device. Rather than letting the traffic connect directly, the proxy firewall first establishes a connection to the source of the traffic and inspects the incoming data packet. As I said, it is not going to connect it directly. First, it will establish a connection to the source of the traffic and inspects how the data is going to send or receive. This is regarding the proxy firewall. Next, we'll move on to the next topic, that is digital signature. Okay. What is digital signature? Why we have to use the digital signature is, digital signature is the mechanism in which we are going to provide the three things, that is authentication, then non-repudiation and the integrity. So it is the signed document by the sender which will help the receiver to identify that it is the authorized one. He will get assured, he will be having the guarantee that it is the authorized document from the authorized sender, and it has not been changed by anybody during the communication or during the transport, and nobody can repudiate that it has not been sent by me. The sender is sending the document, he cannot object that I have not sent it. So these three things are provided by our digital signature. So it is going to be a signed document. Digital signature is a signed document which is going to provide three things, that is authentication, integrity, as well as the non-repudiation. Characteristics of the signature: it should be authentic, not be forgeable, not be possible to repudiate the signature, not be reusable. The same signature cannot be reused. See, if for a particular message I am doing the digital signature, if I will be the same person but I am signing another document, the digital signature will not be same. For every document my digital signature will be different, even though the same person is signing different documents. So it cannot be reused, not be possible to alter a signed document. So the content of the document cannot be changed. That is what I said, integrity. It is going to provide integrity. So how we are going to provide all these things and get the digital signature document? See, we have to apply hashing. So in order to provide integrity, what is integrity? Our requirement is during the transmission nobody should change the content of the data. How we can provide that is using the hashing mechanism. So after hashing mechanism, what we have to do? Authentication, whether it has been received by the authorized person and it has been sent by the authorized person. Both things should be confirmed. So in order to provide that, we are going to use MAC. We are going to apply some function on the data as well as the key. After combining the key, we are going to apply the function and we are going to get some value, that is MAC. And the third one is to create a digital signature. After that, what we are going to do? We are going to encrypt it so that it cannot be used. Nobody can non-repudiate. Nobody can object that it is not sent by me. So what is digital signature? First we have to apply hashing, then we have to calculate the MAC, then we have to go for the encryption. So all these three things together will constitute digital signature. So it provides integrity, authentication and non-repudiation. Okay, first what I have to do, if I want to sign a document digitally, if I want to give digital signature for my document, first I have to write the data or get the data and I have to apply hash on it. So what is hashing? As we said earlier, the hashing is nothing but unlimited data can be converted into a fixed size data by applying hash. Okay, so arbitrary, the message or the data of arbitrary length can be converted to the fixed length, and since it has the one way property, with the hash value nobody can get the data, but with the data we can get the hash value. So this is the advantage of the hashing. So we'll get the message digest after application of hashing on the message. With the message digest, what we have to do is, if you want to send the key, if it is going to be private key cryptography, you can apply hash and we can append the message with the key, apply hash, then you can send it after the encryption. If you don't want to use the private key cryptography, then the direct method is you can go with the application of the encryption method using RSA. Just calculate the hash on the message, you will get the message digest. On the message digest, you have to apply the encryption with the private key of the sender. So after receiving the data, the receiver will decrypt the message digest with the public key of the public key of the sender. So he will get the message digest, and also the the encrypted message digest will be appended with the message which the sender is going to send. So at the receiver side, the receiver will check after getting the decryption, after applying the decryption using the public key of the sender, he will get the message digest, and he will also get calculate the message digest by applying hashing on the data which he has received, and he will get a message digest value. So the message digest value what he has calculated and the message digest value which the sender has sent will be compared by the receiver. If both are same, then he will confirm that this is the data which is sent by the authorized person and which has not been modified during transmission. If the digest value is not same, then he will not accept the data directly, he will reject the data. This is how the digital signature works. So by the digital signature, we can ensure that it is we are going to provide integrity, authentication and non-repudiation. And the non-repudiation is nothing but after sending the data, I cannot object that it is not signed, it is not sent by me, I have not sent this message, because since it is encrypted by my private key, I cannot object that it has not been this. Since the private key is known only to me, nobody can use my private key. So this itself will provide a guarantee that it will provide the conformance that only I have sent this message. So we can also ensure this non-repudiation by using the digital signature. So what is digital signature? It is nothing but a electronical kind of signature included in the message as a proof of authenticity. And as we have seen, three mechanisms we have to use. One is hashing, MAC and the encryption to provide three things, that is integrity, authentication and the non-repudiation. With this, I am completing this session. Thank you. Bye bye.